Hi and welcome to what I'm hoping will be the first of several videos on the focus module within within Kstars Ekos. As always, it's difficult to know quite where to start because there is a lot of functionality within the module, but I think maybe a good place is just to make this video an introductory video to the focus module, not attempt to go into too much detail on any one specific topic, but really give you an overview of the features. And also for folks who are either new to astrophotography in general or new to Kstars, perhaps coming from another package or looking to potentially start using Kstars, I'm hoping this can give you a bit of a good place to start in terms of trying to work out what you'll need to set up in order to get focus working for you. So what I've done here is I've fired up Kstars on my laptop with an optical train of really the simulators in order to sort of produce this video. So it's somewhat idealized in terms of the outputs, etc., that we'll get, but I think it should be informative nonetheless. So this is the focus tab with the magnifying glass to signify that we're on focus. I'll go through the main elements of the screen just so folks get a bit of a view of everything that's available. So at the top is the optical train. You'd obviously, under normal circumstances, select the optical train that contains your main imaging camera. Obviously that will be what you would want to get in focus for collecting subs, etc. The next section of this contains information about the focuser that is associated with that optical train, which in my case is the focuser simulator. You have some information about where it currently is, 36700. You can adjust that by specifying a position to move to, and then hit this button which will move to that position. You can move in or out by the step size that's set elsewhere, and I'll come to that a bit later. You can start autofocus. You can start framing, or you could just take a subframe. So if I press that, what the system has just done is it's taken a 2-second subframe through the primary optical train, and it's displayed here in this FITS viewer the output. So you know, there's a bunch of stars, the HFR is highlighted for each of those stars, and just down here it's probably worth saying that this HFR number 1.02 is the average of the HFRs in the frame that's just been taken. So if I do another one, hopefully we'll get a slightly different number, 0.98 this time. So that's a good way of kind of seeing what your HFR is doing if you're, you know, a bit curious. So a good feature that enables people to get near to focus to start the process is this framing option. So if I just start that, this V-curve widget sort of transforms itself into a timeline, and what's actually happening is it's taking a bunch of subframes, it's analyzing them, and it's giving the you know, the average HFR, and then it's representing each of these subframes on this graph here. What I can do is I can sort of move the focuser around a bit, so I can start to go in by 1 step size, and what you can see is that the frames are now showing up as with a higher HFR as I'm moving sort of out of focus. So if I continue doing that, you'll see that the focus is getting worse, the HFI is getting larger. So this is a good way of, if you're unsure where your focus point is for your equipment, this is a way of sort of moving the focuser around and getting some sort of real-time feedback as to, are you getting nearer or further from focus. The thing to bear in mind is if you go too far away from focus, you probably have lost all of the stars and you're probably just detecting noise, and what you're getting isn't necessarily very representative. But as you get somewhat near to focus, this will become more meaningful. So I think this is, as I say, quite a useful feature, particularly if you're new to your equipment and you're trying to find your focus position. So I'm just going to stop that now. You can see the focus position is now at 36688, and if I were to hit this button, I would move it to whatever's in this field here. So in this case, 36700. Okay, so that's the framing option. If I come down here to the information about the camera, and if you have a filter wheel attached with filters, you can get some information about that. So you'd have to set up how you want focus to use your camera. So you'd need to specify your exposure length, binning, gain, and if you've got a digital SLR, you'd specify the ISO. I think some things to bear in mind. You don't want to go too short on exposure. 2 seconds is a reasonable start. If you are at a longer focal length and you're gathering less light, you may need to increase the exposure above that. If you're on a narrowband filter, which is obviously inhibiting a lot of photons from reaching your sensor, then again you might want to increase the exposure. I wouldn't go below 1 second. I think just going back to what you're trying to achieve with focus, what you're really after is you're trying to get an averaged out view of a star. You're not trying to see the airy disk or anything like that. What you're really after is a seeing sort of smudged out star, which will change in shape as you move in and out of focus, or change in size rather. So going below 1 second, I think probably you might start to hit problems. So we're going to leave that at 2, and we'll see where we go. If you have a filter wheel attached with filters, you can see them in here. A good place to start would be like a luminance filter that's going to allow most light through. Obviously you can pick any of the filters you want, but bear in mind if you are going to look at narrowband filters, you probably want to increase the exposure time. Binning, generally I would start at 1:1 binning, and I would only really increase it if you're starting to have problems. The problem with increasing the binning is you're potentially losing a little bit of detail. Although obviously you are potentially making your stars brighter because you're adding together the smaller pixel sizes into sort of a larger sort of composite pixel. It may work in some situations, and by all means give it a try, but I'd start at probably 1:1 and see where you are. Gain, I think a good place to start is sort of the unity gain for the camera that you have. So if you if you increase the gain higher than that, potentially you might find more stars, but you also run the risk of having more noise getting detected as stars. If you have it set too low, then you may not be seeing enough stars. So, you know, play around with it by all means, but a good place if you're unsure where to start would be, you know, look up the unity gain value for your camera and start with that. If you have any temperature sources attached, they will show up in this pop-up, this drop down here, so you can select whatever the best one is for you. Filters I've kind of already talked about. The next sort of tab widget here, which consists of 5 tabs, really gets into a lot of the detail of the various settings that you can set for the focus runs. So I'm going to go through some, but not all of these, and some of the areas I'm going to really avoid and come back to in subsequent videos. So we'll start off, I think, just by, you know, running an autofocus. Now I happen to know that the simulator's focus position is around 36700, so I'm starting it from there, so we should end up with a symmetrical curve. For your real equipment, it doesn't you don't have to start it exactly at focus, but you do need to be in the right sort of ballpark, so it is worth getting, you know, somewhat near to focus before you hit the autofocus button and start the run. Some of the algorithms are a little bit more tolerant to being further away from focus, some are a little bit less, but you will need to be in the vicinity for them to work, because if they can't detect stars, if you're so far out of focus that you can't see stars, you know, none of the algorithms will work. Okay, so it's run through and it's taken a number of subframes and it's plotted a nice graph for us. So what it does is it starts off by moving to a higher focus number, which should correspond to moving your focuser out. It then takes a subframe, in this case number 1, it analyzes that, calculates an HFR, then moves the focuser in by the step size, takes another subframe, works out the HFR, plots it on the on this V-curve graph and keeps going. It's done 11 points on the curve. It's then worked out that it's worked out what the minimum of this curve is. In this case 36796. So it's now moved the focuser back to 36796 and taken one more frame, which is why it says the iterations here are 12. So you've got 11 data points and then 1 when it's moved the focuser back. So 11 plus 1 is 12. So that's kind of the basics of this V-curve. Now, this is an idealized simulator, so it sort of kind of looks, you know, nice and perfect. The you know, the data points are all on the line, you know, etc. When you run in real life, it won't be quite as good as this, but there's probably a few things that are worth saying. You know, the first is you need a reasonable difference between the HFR that's calculated at the minimum, which in this case is around 1, and the maximum HFR that you're calculating, which in this case is whatever that is, 3.4 probably. So, you know, if you end up with a very flat curve where there's very little difference between the minimum and the maximums, then your curve fitting process is subject to, you know, the vagaries of trying to fit somewhat noisy, or a curve to somewhat noisy data. So try to make the furthest out data points as different as you can in terms of HFR as the HFR you're getting at your minimum. Now that's kind of easy to say, and for some, you know, for sort of forgiving rigs which you know, are somewhat easier to focus, then that's quite achievable. If you have, you know, a long focal length reflector, for instance, with a central obstruction, what you'll end up getting as you move further away is you'll end up with donut stars. Now, the problem with donut stars is that they don't get detected very well, and they start to confuse the star detection algorithm, and the HFRs that it starts coming up with tend not to be very good. So you can't really go further out of focus than the point at which your star detection starts breaking down. So the challenge is to kind of move far enough away from focus to have a reasonable difference between the HFR when you're in focus and out of focus, but not move so far away that the star detection starts to give problems. Now, it's kind of impossible to say, you know, here's the exact formula that'll work for everyone, but I think that sort of principle, move as far away as you can until the star detection starts breaking down and the HFRs become unreasonable, is probably the best sort of rule of thumb that I can give on that. Okay, so we've now got a reasonable sort of curve. Everything looks quite nice and symmetrical, which is kind of what you like. If you end up over on this side with the first few data points being in a more or less a horizontal line rather than sort of conforming to this, in this case, hyperbola, one of the reasons for that is that you have some uncorrected backlash. So what's actually happening is on the first point, when the focuser moves all the way out to from its starting point to the first point, and then starts moving back in, it's not actually moving back in. What's actually happening is it's taking up some of the backlash. Now, what'll happen there is you'll end up with HFRs that aren't moving as the focus is moving, so you'll end up with a bit of a horizontal line. So if you do have a horizontal line over on the right hand side, one thing to look out for would be uncorrected backlash. Okay, so this is kind of the basic setup for running autofocus. So I'm just going to go through some of the tabs now, down towards the bottom left of the screen, and just say a few things about some of the fields. I'm not going to go through all of them, and some of the areas I will not really say anything about, but revisit in other videos. So the leftmost tab is called Settings. It's got some general settings that configure the way focus works. Probably a reasonable place to start would be just to touch on a couple of these checkboxes at the top. So suspend guiding, if you are using an off-axis guider, you probably want to suspend guiding when focus is running. It's worth, you might want to just try it and see what happens, but generally what will happen is as the focuser racks in and out, guiding will get confused and start to go haywire. So if you tick this suspend guiding box, then as the focuser is moving, guiding gets suspended and doesn't go haywire. If you don't have an off-axis guider, then you may be fine leaving guiding running whilst you're focusing, in which case no need to check that box. Dark frames, if you wish to, you can take some dark frames. It's a feature on the capture tab. So set up dark frames for the camera that you're using. Obviously, the primary the camera attached to the primary optical train in this case, and providing that the dark frames you take match the parameters that you're using in focus, 2-second exposure, binning 1 by 1, etc., then if you tick this box, then as your focus frames are taken, they will be dark frames subtracted before being processed. I haven't personally found that this has made much difference to my focusing. but then I have a somewhat forgiving rig, so it may be that it's just doesn't work particularly for me. It's not that it makes it any worse, it just doesn't improve things, so I tend not to use it. But you know, again, it might be something that's worth a go if you know, if you have a spare few minutes. It doesn't take long to set up and it's easy to do. The next row of buttons probably does require some explanation. There's a couple of options here: full field or subframe. So you either have one or the other set. What this essentially means is that if you have full field, what that is saying is use multiple stars and then use statistical averaging to work out things such as the HFR. If you have subframe selected, what that is saying is use a single star. So generally, I think for most people, most of the time, you're going to get a better result using multiple stars and statistical averaging. But you know, there's no reason why you can't use a single star, and you know, there are probably some specialist uses where that is the best way to go. So Ekos does support that. Select subframe. You then have the option of either having Kstars detect the star itself, so just tick the auto select star, or leaving it unchecked, and in that case you have the ability to select which star you want. So the way to do that is you go into the FITS viewer, pick your star of choice. In this case I'm going to have this one, click it, and Kstars will put a box of, in this case, 128 pixels around that star. And you know, you can, for instance, just go and hit autofocus, and Kstars will then run focus for you, but it will only use this one star. So things to note whilst that's running are that the number of stars detected is 1, which is what we've specifically asked for, and the HFR here is not an average. It's the, you know, it is the HFR of that one selected star. So this works fine. Obviously you don't get the benefits of any statistical averaging that you would have were you to be using full field, but as I say, there may be some selected specialist uses where this works better. So we'll just let this run through to completion. And there we are. It's done a perfectly good curve fit for us and found, you know, a perfectly acceptable value of focus. Okay. So moving on then, you can display the HFR values in pixels or arc seconds. This is interesting if you wish to restart, or it's really a settling time that you can set. So once autofocus is finished, before guiding starts back up, you can, if you wish, set a number of seconds here to wait before doing that. The next set of options refer to how much of the focus, how much of the sensor you're going to use for focusing. So again, this would really only be relevant for using full field where you're using multiple stars. So it's set here on use all the stars, so it's basically using all of the frame. If you wanted to put a ring mask on, this is the place to do it. So for example, if I didn't want to use the edges of my sensor because, for example, I don't have a flat field all the way up to the edges and I don't want that affecting the HFRs, then I can put a maximum outer diameter on. And if I didn't want to, if for instance I was photographing, let's say a globular cluster, and I didn't want to use the stars in the cluster because it was getting confused, I could exclude that by you know, maybe setting this to say 20%. So what this is going to do is, if I just run focus again, what this is going to do is it's going to only look at the stars within the inside the outer ring and outside the inner ring, if that makes sense. So you can see there are now two rings. There's an inner ring which is at 20% of the size of the sensor, and then there's an outer ring that's cutting off the corners, and it's only looking at the stars within that torus or ring for the purposes of focus. So that can be quite useful if you have equipment that perhaps doesn't have flat field all the way to the edges, and or you're having problems focusing with stars on a target that is causing you problems. Okay, I'm not going to say anything else about adaptive focusing. I'll cover that in another video. So that's kind of it for the settings tab. If I move on to the process tab, this is kind of to do with the process of sort of star detection and curve fitting. So I'm not going to say a lot about this, but generally, although there are a number of star detection methods that are supported, I think generally I would encourage people to use SEP, which is it's kind of a utility library that's been around for a long time. It's quite stable, does the job, and is quite flexible. That's not to say that the other methods can't be used. They obviously can, but if you are looking for a place to start, I would start with SEP. Now, associated with SEP is a profile of parameters. So if I just click this little pen here and bring up the profile editor, you can see that there's quite a lot of stuff in here. As far as where to start, I would start with the focus default profile. What I would say is, although you can change the focus default, what I would suggest you do is create a new profile and base it on focus default, and then adjust the parameters you want to adjust. That obviously gives you a method then of going back to focus default should you decide that you want to go back to the standard one. So I've created a profile here called My Play Profile, and I can play around with this, and then if I want to go back to focus default, I can. So I'm not going to say too much about this because we'll be here forever if I do, but probably the thing to just make sure that you're sort of, you know, having have reasonable numbers for are that you are keeping a reasonable number of initial stars before sort of processing them, so you're not throwing them all away. I would suggest that you do, if you are doing relatively long exposures for the focus frames, that you do eliminate any saturated stars. If you're suffering from hot pixels, it might be worth putting a minimum size in here, maybe just above 1.1, something like that, just to stop hot pixels getting, you know, confusing the situation. There are other methods to kind of eliminate those, but you know, I think we can go back to like the dark frame subtraction that I mentioned at the start. That would be one way of doing it, and there are other ways with the other parameters. But if you do believe you're suffering from that a little bit, then that's something that you could look at. Other than that, I'm not going to say too much about this because these parameters are quite complicated to set up and get to work. So I would as a starting point, just use the focus default, and just leave it at that. Don't worry about it too much. I would suggest using the linear one pass algorithm. There are 4 algorithms available. I think most of the new toys are in linear one pass, so that would be the one I recommend using. With linear one pass, you can fit 3 different types of curves. Quadratic really is kind of a deprecated fit at the moment. It's using an old solver that has been replaced, and in essence, conceptually, it is identical to parabola. It's just using some old code. So if you're on quadratic, I would just move to parabola. Differences between hyperbola and parabola. I personally use hyperbola, but I think you can get perfectly good results with parabolas. There are some sort of technical reasons why. Probably if you're able to move your focuser a long way away from focus, your curve is probably more likely to be a hyperbola in shape than a parabola. Whereas if you perhaps have a scope with a central obstruction that causes donuts that prevent you from moving too far away from focus, then maybe your curve is more parabolic in shape than it is hyperbolic. But I don't think I've observed there being much difference between the two. So personally, I'd use hyperbola and leave it at that. So the measure is what type of thing is going to get used to work out where your focus point is. I'm going to cover some of these other measures in other videos, but I would leave it at HFR for now. HFR has been around in Kstars for a long time. It's very stable, and it works well. So just leave it at that, and that's that really. I would recommend checking use weights. So what use weights will do is it will weight each of the data points. So these 1 to 12 data points on the V curve, and it'll weight them based on the standard deviation of the HFR. So the theory of that would be that if you have a data point where the HFRs are very close to one another, the standard deviation would be relatively small, and that data point would be potentially weighted higher than a data point where the standard deviation of the HFRs is higher. So I think generally what you'll see is that the in-focus data points get more weight than the out-of-focus data points. Plus, if you get a bad data point and there's a really small number of stars, the standard deviation is going to likely be higher, and therefore that data point would receive less weighting in the curve fitting process. So I think in general it is better to put weighting on. The refined curve fit is a newish feature, so it's not the default option, but I think it's been working quite well, so I think it's worthwhile putting that on. And what that will do is at the end of the pass, so in this case after having done 12 data points, it will attempt to optimize the curve, and there's a few optimizations that it does. So it will attempt to fit a more accurate curve, and it will potentially look for outliers in the data points. And if it finds them, it will exclude them from the curve fitting and rerun the curve fitting without the outliers. So I think it works reasonably well. It's been live for a little while, so it's worthwhile putting on. One of the uses of it is people have noticed that if you get a bad data point, even though the weighting might help you by giving that data point a low weighting, that's not always the case. And even if it gives it a slightly lower weighting, it can still distort the curve. Whereas if the refined curve fit detects it as an outlier, then it will actually remove it from the curve fitting, which can be very helpful. So yeah, if you've not used it, put it on and give it a go. The R2 limit, so the R squared number is a measure of how well the data points fit the line. So if you have a curve where all of the data points fit the line and they all sit exactly on the line, then your R squared will be 1. If you have a random series of data, so there's no obvious sort of correlation between the data, then your R squared will be 0. Now, obviously, in this example, the curve fits pretty well the line, so the R squared is coming up as 0.99. I've got a limit here of 0.90, and what that will do is, if I'm, for instance, running my rig unattended, if an autofocus run happens and if the R squared comes out below 0.9, then it will attempt to rerun focus. So if, for example, you happen to run focus and there was a bad gust of wind and it caused a problem for your focus, then it will attempt to rerun. It will only do the rerun once. Obviously, if you have a systemic problem and focus is just terrible, then keep rerunning it isn't going to help. So it will have a go once, and it'll just take whatever it has at the end of the rerun. So that's all I'm going to say on process. The next tab, mechanics, is really to do with focuser and the mechanics of how that focuser moves. So this field here, walk, is how the curve is drawn. I'm not going to go into too much detail, but probably if you're starting out, pick classic and just leave it at that. Classic is slightly more tolerant of being further away from optimum focus when you start the autofocus run than some of the other algorithms. It is slightly less efficient in terms of how it works than some of the others, but unless you're obsessed with efficiency, I wouldn't worry about that too much. So for example, this 0.12 probably technically didn't need to be taken, and it hasn't added anything. We could have finished at 11, but the classic algorithm has put another point in there, so it's slightly less efficient. It's done another data point when it probably didn't need to. But as I say, it's slightly more tolerant of not starting at the optimum point. So if you're looking for a place to start, it's with classic. Step size. The initial step size is a tricky parameter. It is very important to get this step size pretty close to what it needs to be, otherwise you probably won't get good results out of focus. And it's not so easy to know what to pick as the step size. I guess you can sort of get to it by trial and error. Going back to the shape of the V curve, you need to have, if you have a step size that's very small, the difference between HFRs on your sort of in focus data point and your out of focus data point is going to be very small, and that's not going to result in a very good curve fit. So you want the step size to be somewhat large in terms of being able to get you a difference of HFR that you can then fit a curve to. But it's not always obvious what to pick. So probably the best method of finding something is to start off by putting the initial step size around about the critical focus zone. So if you don't know what the critical focus zone is, you can Google it. There's a lot of information available, and Kstars does support a number of algorithms to calculate the critical focus zone. But the concept of the critical focus zone is that either in or out of focus, there's a zone around the point of optimum focus that really you can't distinguish the degree of focus in. So if you said that the critical focus zone was 100 ticks, then what that's saying is if you went from the point of optimum focus either out by 50 ticks or in by 50 ticks, and you took a number of subframes at each of those focus points, you know, the middle and each of the edges, then you wouldn't be able to tell by looking at those subframes that your image was any different. So it's sort of a zone of you know, in which you can't really tell a difference in focus. Obviously, if you move outside of the critical focus zone, then you would start to see a degradation in your subframes, and things would get more and more blurry as you went further out of focus. But the point of the critical focus zone, or one of the points, is you can, if you set it up correctly, get out of it a number of steps, and as a starting point you could set your initial step size to that number of steps. Now this is a simulator, so I've had to sort of set a few things up to get the answer I want, but the important parameter that you need to set up here is this step size, and this step size is, so for each of your focuser steps, how many microns does it move the optical plane? So in this case I've set this up to be 0.01 microns, and this is a bit of a quirk of the way the focus simulator is set up. On my real rig I think it's around 15 microns, so every tick on my the focuser on my rig corresponds to a movement of 15 microns of the optical plane. So you'll need to calculate that for your equipment, and if you put that in there, then this tab will calculate the critical focus zone in steps for you. So as you can see, as I move this around, so the critical focus zone number changes. So I've got a number there, 7750. I could use that as the initial step size. It's a reasonable way of starting. You may want to, having, you know, got a number to start with, you may want to play around with it and optimize it. If you tick that, what this will do is it will put this little yellow upside down moustache on the curve, and this represents the scale of the critical focus zone. So if I just go back and change this, oops, that's too small, you can't see it. You can see it's very tiny there. So as you adjust things, so the width of this yellow moustache will change. Back to the mechanics tab. I'm going to leave this at 5000, but as I say, if you are struggling to know what to set that to, start by setting up this critical focus zone tab. The one parameter you do need to put in that you will have to calculate yourself is this step size. You know, a way to do it is to rack your focuser from, you know, furthest point out to furthest point in. Measure, you know, if you've got a nice refractor, it's easy. You can just measure how far the tube moves with a, you know, if you have some calipers, that will be quite accurate. If not, a ruler. Work out how many steps your focuser has moved to rack the focuser all the way in and out, and then from that you can calculate the step size in microns. Okay. So the outstep multiple really is how many steps when you start focus it is the focuser going to move out. So in this case, it's moved out 5 steps, and then it's come back in those 5 steps. It's then gone well, a few more steps the other way, and then it's drawn a curve. Max travel, I think most focusers now have sort of protection built in, but you can specify some a parameter here whereby Ekos will stop you moving the focuser more than a certain range if your focuser doesn't have its own built-in protection. The next two fields relate to backlash. And again, this is something you will have to get right for your equipment. So backlash really refers to when you change direction of the focuser. The problem is that because it's will have some physical gearing, or it probably has some physical gearing, the gearing will have a gap, and as you change direction, and the cogs mesh, or the equivalent of cogs in your focuser if it's different, that will result in there being like a dead or a flat spot, whereby you're moving the focuser a number of ticks, but it's not physically moving the device. Now that messes up a lot of things, so it's important that you get that sorted out for your equipment. So there are really, I suppose there's kind of 3 ways that you can sort this out. One is you might have a focuser that handles it for you, and you can just set some stuff up in the focuser and set everything in Ekos to 0, and as far as Ekos is concerned, there is no backlash, and if your focuser supports that, that's fine. Alternatively, you can set it up in Ekos, and there are 2 ways. So there's, if the driver of the device supports backlash, then you can calculate a number and put it in this driver backlash field here. And that's fine, and that works fine. The only slight problem with that is that you have to sort of specify an exact number. So you may calculate your backlash to be 100 ticks, and then what will basically happen is the driver will manage, when you change direction, adjusting for that backlash by moving the device 100 ticks more than you've asked it to move, which caters for the backlash. The problem obviously is though that it's hard to know exactly to the number of ticks what your backlash is. So on my equipment, for instance, if I measure the backlash on my ZWO EAF, I might get 90 ticks one time, the next time I might get 105 ticks, and the next time I might get something else. So I know it's roughly 100, but it's hard to know exactly what the number is. So in my case, I use the autofocus overscan rather than the driver backlash. So I leave driver backlash to 0, and I put something like 150 in here. Now what that'll do is on outward movements of the focuser, it will add 150 to the movement. So if I was moving the focuser, let's say 500 ticks outwards, it would move it out by 500 plus 150 equals 650 ticks. It would wait for that movement to complete, and then it would move it back in by 150 ticks. So the net result is it does a double movement of 650 followed by an inward of 150. So net it's moved the focuser outwards by 500 ticks. On inward movements, it just moves it by whatever you want. So the advantage of doing this, it may sound quite complicated and you're probably thinking, why would I want to do this? The advantage is that you don't actually need to specify the exact backlash. As long as the number you put in here is bigger than your actual backlash, then it'll work fine. So In my case, if on my ZWAEF, the backlash is about 100 ticks. So I usually put 150 in here. I could equally put 110 or 200. It'll work fine because I don't need to specify the exact number. So I think on my equipment, the overscan works better than specifying backlash, but obviously different equipment works differently. The next two fields are just timeouts. So I would leave the defaults at 30 seconds unless you have a reason to change those. So that is kind of basically the sort of overview. There is one other tab here that I'm just going to mention, which is this Focus Advisor tab. So the purpose of this is really to get people starting when they're coming to focus for the first time in Ekos. So the idea is that this will set some sensible values for you to start the focusing process based on just some common sense and the equipment that is connected to the optical train. So you can see in my case it's saying, okay, it knows there's a refractor at 550 millimeter focal length, and the image scale of my camera attached to the telescope is 1.95. So it's going to come up with some suggestions. So the first couple, which are very, very difficult for most people to set because they don't really know quite where to start, is the step size. And if you remember, it's picking that step size up from the critical focus zone that we talked about a little while ago. Again, you don't need to accept that. If you uncheck that, then when you hit the update parameters, it won't update that value. Outstep multiple, I think 5 is a good one to start with. That gives you 10 or 11 data points, which is a good start. You might want to optimize that one way or the other, but again, you know, the more data points you have, probably the better the curve fitting, but you can't go too far away from focus because then you're you know, you'll probably be into donut zone. So you know, a good number would be, you know, maybe 9 or 10 or 11 data points, which corresponds to around about 5 here. The way these other labels work are that, for instance, the camera and filter wheel parameters just refer to this section of the screen here. Again, it's going to recommend some exposure times, and it usually recommends a bin of 1 by 1. You'll have to set the gain and the filter yourself. But again, if you wanted to update this, just leave that checked. And then the remaining 3 labels will set correspondingly the parameters for the settings tab, the process tab, and the mechanics tab. And again, it'll tell you if you just use the mouse hover over what it's going to set, and assuming you're happy with that, or if you don't know enough to have a view on it, then just go with what it's recommending. And then if you hit update params, it will update all of the parameters appropriately, and hopefully that is enough to actually get you started with the focus process and then from there, you know, you can play around and maybe tweak it to get better results. Okay, so I'm just going to run focus one more time because I've changed a couple of settings. Just explain that. Hopefully we'll get a reasonable curve this time, and it'll help. So you'll notice that we've now got these error bars on the data points. So this is because I ticked use weights earlier on. So what it's doing is it's looking at the HFRs associated with each of the subframes, and it's saying the standard deviation of those HFRs is higher on 0.1 than it is on 0.5, for example, which doesn't have much of a standard deviation. So the net effect of that, and I think this is a fairly common theme, not just on the simulator, but in, you know, real life, is that your in-focus data points will have a higher weighting than your out-of-focus data points, which is probably what you'd want. Now, unfortunately, it hasn't done what I was hoping it was going to do, which is it hasn't actually excluded any of the data points. So I did have refined curve fit on. So I think it's looked at these and it said, well, based on the data here, all of these data points look reasonably valid, so I'm going to leave them alone. I'll just give it one more go, and maybe it will exclude one or more of those data points, and I'll just show you what that looks like on screen. Basically, the data point just gets marked as excluded, so it doesn't take part in the curve fitting process. So anyway, we'll see if this does what I'm hoping it will do. If it does, great. If not, then I'm sure on your own equipment it'll be more obvious than it is on the simulator, which is obviously giving rather a lot of sort of idealized data, and therefore it's not quite as random as sort of real data will end up being. Oh well, it didn't exclude any data points on that run either. So I'm going to kind of call it quits on that, I think, and kind of bring this this first focus video to a close. So thanks very much for getting to the end. If you have any comments, obviously that would be great. As I say, I think this is going to be the first of probably several focus videos. So in the subsequent videos, I will be going into a little bit more detail on certain aspects of focus and how you can configure your rig with Kstars and Ekos. So until then, thanks very much.